Okay, folks, we're going to go ahead and get started. Um, so this is just a little bit of information about what we have talked about to date about the atoms of the elements. The atoms of the elements are found on the periodic table. Each element has its own unique symbol and unique name. The symbol often reflects the name, but there are some exceptions to that rule, mainly those that are known to the ancients and therefore have Latin names originally or German names or something of that nature. The atoms of the elements consist of three subatomic particles. Those particles are the proton, the neutron, and the electron. The proton is a +1 charge. It has roughly a mass of 1.00767 AMUs. It is found in the nucleus of the atom, and the protons are responsible for the element's identity. If you alter the number of protons, you alter the element. It'll no longer be the same element. The neutrons have no charge. They're slightly heavier than that of the proton, weighing in around 1.00867. The neutrons are also found in the nucleus, and the neutron is responsible for the isotope of the element. So as long as, what that means is if I go dig up carbon, I will find, and I take a sample of carbon and I run it through an instrument called a mass spectrometer. I will find that there are two types of carbon. One is carbon 12, which is the most abundant of the carbons, and one is carbon 13. The difference in carbon 12 and carbon 13 is the number of neutrons. And so those are isotopes of one another. Then you have your electrons. The electrons are a negative one charged subatomic particle. The electrons themselves have relatively little mass. They weigh in at around 0.00055 AMUs. They're usually found they are found in the electron cloud. And the electrons are what is responsible for an element's reactivity. When we start making compounds, it's going to be the electrons that are going to be shared or the electrons that are going to be transferred in the process. Some other terms we talked about included the atomic number. The atomic number is found on the periodic table. In the one on the wall, it is the blue number up at the top of each square. That number is representing the number of protons. It also, in a neutral atom, it will tell you the number of electrons. And we also talked about the mass number. The mass number is a whole number. It is the number of protons plus the number of neutrons. And because, well, protons are counted, neutrons are counted, and since you can't have a half of an item, that's why it is a whole number. Lastly, you have your isotope symbols. Now, the one that you worked with a lot on Wednesday was the one where you had the name of the element or the symbol of the element followed by its mass number. So like lithium 7, helium 4. Those are examples of an isotope symbol. Now, an isotope symbol, however, can be written in a variety of ways. The most explicit of the forms is actually this first form, where you write the element symbol. The X is just any element symbol. So it could be carbon, so it'd be C. It could be silicon, so it'd be Si. It's just representing the symbol. You have your element symbol, and to the left as a superscript, you put the mass number, and to the left as a subscript, you put the atomic number. It's the most explicit because the atomic number and the element symbol basically are telling the same story. So an example, let's just do the carbon one. So carbon 12, 6. If I look at the periodic table and find my the element C and look at its atomic number, it is a 6. So those are telling the exact same story. So for me, the second version and the third version tend to be just as useful. So I will tend to use the second or third version. Now, what we're going to get into today is we're going to talk about the average atomic mass. And the average atomic mass takes into account all naturally occurring isotopes of an element and their abundance. So I mentioned a minute ago with respect to carbon, carbon has two naturally occurring isotopes. It has carbon 12 and it has carbon 13. If I were to look at potassium, potassium has three naturally occurring isotopes, K39, K40, and K41. Calcium has six naturally occurring isotopes. It has Ca40, Ca42, Ca43, Ca44, Ca46, and Ca48. And no, I'm not asking you to memorize these. One reason I put them up here is because, again, carbon had only two, but you can have more than just two naturally occurring isotopes. Technically, you can have fewer. Fluorine only has one. So, and the other reason I wanted to illustrate, I didn't want you to get into your head that they always are going to go up numerically, because they don't. Like calcium, you skip 41. So they're not a numerical system either. So that's why I wanted to put up calcium and show you that you can have a ton of these things. Now, the other half of the story, though, is their abundance. Who here has had any type of chemistry? Okay, I've got a few. And so I am going to say this. High school teachers love to say that the mass number is on the periodic table. And that is incorrect. So I've got to break, anybody that's had chemistry, I've got to break that statement now. The mass number is never on the periodic table. What is on the periodic table is the average atomic mass. Now, the second thing I want to mention about that, though, is a lot of times by looking at the average atomic mass, however, you can predict the most abundant of the isotopes. By looking at the periodic table, you can predict the most abundant of the isotopes. So, for example, carbon has an average atomic mass of 12.0108. So which of those two forms of carbon is probably the most abundant? 12, because it's closest to that number. Potassium has a mass of 39.0983. 39.0983. So which of the potassiums up there is probably the most abundant? 39, because this is closer to 39. So high school teachers, they tend to use those terms interchangeably, but they're not. And so it is my turn to break that habit and actually teach you how to determine that red number on the periodic table, which is known as the average atomic mass. Now, before I get into that, let me ask you another question. If I were to give you 3 tests and I ask you, what is your average, how would you tell me? You'd add them all together and divide by the amount of tests. So in other words, you take into account all of them, don't you? When we get into the average atomic mass, we have to take into account all of them for an element. And there's a nice little formula. I give you formulas on an exam, by the way. The only ones I will not give you, you will not receive this formula on the test, but I'll give you the next one. The average atomic mass is equal to the sum over all naturally occurring isotopes of the mass of the atom times its abundance. So let's go back to carbon. We have carbon 12, we have carbon 13. Carbon 12 has a mass of 12 12.103 4, 5, 6, 12.00000. In fact, all atoms' masses up there are based off of the original carbon. And its abundance this form of carbon occurs 98.93% of the time, or in other words, its abundance is 0.9893. You will notice I said the percent, but I said 98.93% of the time. But when I'm doing the math, I need just the abundance. So I took it out of percentages. Take percent abundance out of percentages if it's given as a percent abundance. Carbon-13 has a mass of 13.003355, and it occurs 1.07% of the time, or its abundance is 0.0107. So again, it's the mass of the atom times its abundance. So we're going to multiply those together. And when you do the 12 times 0.9893, you find that carbon 12 contributes 11.871600 to the overall mass. You don't have to worry about the 00. And carbon-13 contributes a mass of 0.1391 to the overall mass of carbon. So it's the sum of, that's what the capital sigma is sum. So now we add them together. And I get a value of 12.0107. This one was 12.0108. That's where it comes from, folks. These numbers take into account the mass of every isotope times its abundance. And it doesn't you're not going to necessarily get the exact answer. They're going to be pretty darn close though.
I don't know if you were mentioning, is there a way to find abundance?
Okay, so as far as the abundance, what we do is we find the percent abundance using a mass spectrometer. It's an instrument we use. And so I actually don't know the abundances myself. I always have to look them up. And there's an entire 5 pages worth of the various naturally occurring isotopes and their abundances. So you'll be given it on a test. I can't expect you to know these things. I don't know these things.
Is it the same with the mass too?
Is it the same with?
Yeah, like same time and number.
Yes. Those also come off of the instrument. Both of those pieces of it. Basically, what we get when we run this through the instrument. is when we run this through the instrument, nothing happens. And then all of a sudden we'll get a spike at 12, and then nothing happens. And then we'll get a spike that's right past 13. What we do is we determine the area under the curve to get our percent abundance. With the two curves having to equal a whole. And to get the mass, we look at where it comes off on this. So this was just past 13, and so that's where that 0.03355 would come, whereas this one would have been at 12.000000. So that's how we get it.
Okay, so to clarify, those numbers never change.
The numbers at this time haven't changed in a long time for your basic elements. If they change, they're like in the 4th and 5th decimal place, which is not really enough to say it changes. Other questions? I like these questions. They're good questions. I rarely get asked how we actually get it. So awesome questions. Okay, so let's just look at how it would appear on a test. And then we're going to work, I'm going to give you problems to work. To see how it's going to appear on a test, I'm going to do potassium. Actually, I've got 2 more things I need to do, but potassium has 3 naturally occurring isotopes. They are shown in the table below. Calculate the average atomic mass for potassium. And I always say, show your work. Okay. And I'll let you catch up because that's a lot of numbers to write. first thing you're gonna have to do, by the way, is remember the word. It was mass times abundance, not percent abundance. So you're gonna have to take those percent abundances and get it just to the abundance by dividing it by 100. Because it is the mass that you multiply by the abundances. And then you can do the math. And when you get done, you'll get an answer of 39.0983. And if you're close, it should come out close. In this case, it was exact, 39.0983. You do not have to take it, you can just multiply through each line, by the way, folks. Up here, I didn't leave myself enough space, but I could have gotten an answer for this first piece, and then an answer for the second one, and an answer for the third one, and then ultimately added those together. If you don't feel comfortable just keying it all in. Yes.
So, you found the mass for each of the potassium.
I have the atomic mass for each isotope of potassium. I multiplied it by its abundance and added it together. Yes,
Okay,
that's what it is. So this is the mass times the abundance for K39 plus the mass times the abundance for K40 plus the mass times the abundance for K41. So I just want to make a note before we move on about two different things. Number one is that on active, I can't remember if all the problems I picked had an atomic mass and a percent abundance. But for active, if the atomic mass of the isotope is not given, then use the mass number of that isotope. I can't remember, and that's that superscript. So and it works out fairly well, because if you look back, 39, well, this, if you were to round it, would come to 39. 40, this, if you were to round it, would come to 40. 41, this, if rounded, comes to 41. So that's why sometimes on active, they won't do it. They don't give you all of the digits, but on a test, I will. The second thing I want to mention is, if you are doing my optional homework, which is good for studying for the exam, ignore page 1 of the average atomic mass homework. It's not that that page is difficult at all, but what that page was trying to illustrate is how these values up here came into existence. Those values come into existence because if we think of K39, potassium is element 19. That means it has 19 protons at 1.00767. It has 19 electrons at 0.0005, and it has 20 neutrons at 1.00867. It is these individual masses of the subatomic particles that, when you add them all together, come close, not always exact, come close to what you were given. That's why I'm saying just ignore it though. So ignore that page of homework. Starting on the second page, it's valid for the test. Questions? Okay, I'm going to get, in the last 12 minutes, I'm going to give you one to do. Let's see. Who's a good one? I'll give you magnesium. Magnesium has 3 isotopes. It's magnesium 24, magnesium 25, and magnesium 26. The atomic mass for those are 23.9 1920x1342, 24.985.837, and 25.982593. The percent abundances are 78.99, 10.00, and 11.01. How'd it go? You should have gotten 24.3051, technically 24.3050518651, which I just rounded to 24.3051, which just happens to be the same as what's on the periodic table. Questions? So I want to take just a moment. I will say that this first, to talk about your exam next Friday. I know it seems like it's not that, it's still a long way away, but it's not. I am actually ending because of what we're doing next. I'm ending that information for the first exam here. What that means is I will ask you on the first exam questions about the periodic table and its arrangement. Metals, non-metals, metalloids, main group elements, transition metals, the intertransition metals, the lanthanide series, actinide series, the alkali metals, the alkaline earth metals, the halogens, the noble gases, so all of that arrangement. You will have a significant number of questions where you have to tell me the number of protons, neutrons, electrons, the atomic number, the mass number in an atom of an element, and give me the atomic symbol. A lot like the homework. You will have one or two of these questions that we just went over today. And you will have questions about what I started the day with, meaning this table. The only thing that I won't do to you is I won't make you memorize these numbers. But that table is valid. That is going to be your first test. It is probably going to be the easiest test of the semester. Well, no, not probably. It will be the easiest test of the semester. Because what we will begin on Monday, we will begin new material Monday and Wednesday next week. What we will be doing is we will be taking the elements and combining, we will start talking about the ions that these elements make. And after the test, we'll finish talking about the ions these elements make, and we'll start combining those ions to make ionic compounds and then covalent molecules. The next test, if you're math oriented, the next test is actually the hardest because it's just a hard test. If you're not math oriented, then the next three tests are the hardest tests. But after that, we'll get back into math. But I kind of want to cut the test here because it makes a nice story about the atoms and the elements in the periodic table, and then move on to the next test being about ions and compounds. Questions? Yes.
So, for these math oriented tests, calculators, we can't use, right?
You have to have a calculator. I won't let you use your cell phone. But you can use your calculator. Also on my exam, you will receive your periodic table, or a copy of the periodic table like I gave you. You will receive, and for this exam, you will receive, where did I put it? This formula. So I give you formulas where possible. Any questions? Okay, well, I'm cutting out a couple of minutes early. I will see you Monday for ions.
real quick. Wednesday.
No, we're not, huh?
Yeah, Wednesday,
Yeah.
last Wednesday, when we were talking about the conversations, but I felt like I was.
It's okay.
I do appreciate the different kind of things to get motivated and stuff. It does help.
That's the entire goal is, it's not always everybody's cup of tea. But I am trying, and there's one more game I think is that I'll get to play, and that is bingo. But, my big thing is just trying to help you memorize these things without having to just reiterate and reiterate and reiterate like some people do.
This is the quiz next.
There is a quiz and a new homework that just came up. The quiz, the homework, no, there's a new homework and the quiz, they just both popped up today at about noon or before noon. Between 11 and noon, they popped up. So yes, there is a quiz and there's a new homework that's over this material.
Isn't that active? Because when I tried to do the work, it didn't let me. I think it's past due.
The past due ones, it probably wouldn't, it'll let you see them, but it wouldn't let you turn it in. I've got to work on yours because you're unique in that I am letting you do them. I have to go back in and tell it to send me an email, so I remember to go back in and say, and I will give you through Monday to get it done. But it won't take me long. It's just I gotta go in and tell it that you're allowed an extended time.
Yeah, 'cause I didn't see the quizzes on there.
The quiz just popped up today. Oh, the other two quizzes are on Blackboard. They're in the second folder. They're in the first weeks of information, so that would be August 24th and 25th timeframe. That's where you'll find that. Mm-hmm.
One question, Jay. This kind of scientific method.
That is perfectly fine for ours.
The other thing I was gonna say was, I don't really know the purpose or really the point of this, I don't see the point. Trying to find the average time it's not given to me. Is there any specific reason for that?
So this will be the only time you will have to find it. It is part of, in the future, you'll just look at it up on the periodic table to do the next thing you do with it. So this is the only time, but it is to illustrate the difference between mass number, average atomic mass, and where those numbers come from. They're not just random numbers.
Right.
So, but in the future, you will not have to calculate it yourself. You will just use it.
Okay.
I have these quizzes. Do you want me to drop them off in your office or?
And so you know where my office is.
Upstairs
You
to
were-
our-
You were in my office.
Well, I was here, but you told me where it was, and I actually went up there the other day,
Okay,
but I know where it is.
that's right. That's my big thing is trying to just make sure that you have to come to my office with questions. I don't want it to come down to not knowing where it's at.
Yeah.
For me, that's not an excuse anymore.
Yeah. Yeah.
That's the reason the original comes off.
Thank you. Have a great weekend. Are you gonna be at the football game?
Well, I'll go tomorrow at about 4:00.
Okay.
I'm gonna actually plan to be up here at 10 a.m. working,
Okay.
but it'll just depend upon when 4:00 rolls around, how my husband and I are feeling.
Okay.
If we are feeling like we can handle it, yes. If we're feeling like we can't, no. I'll wait. I will be at family day, I know.
Okay.
I just don't know about tomorrow yet.
Okay. Well, maybe I'll see it.
I hope so. It's just, it all depends. With all my medical issues, it's all dependent upon how I'm feeling that day.
Yeah, I get it.
Right. Well, enjoy your weekend.
You too.